This is section 3.3, number 3, and I wanted to do this whole problem using the organizational form and the chart that I created for you, and just kind of go over how to use it. So this is about a dietitian planning a snack of fruit and nuts. Each ounce of fruit is going to have 0 protein, 2 carbs, and 1 unit of fat. So if we go down to our chart, let X be fruit and Y be nuts. And so we have 0 protein, 2 carbs, 1 unit of fat, and it said 20 calories. All right, let's go back up here. And each ounce of nuts, 3 protein, 1 carb, 2 fat, 32 calories. So I'm going to go down here, and these are going to be Y's. This is 3Y, 1Y, 2Y, and that's going to be a total of 32 of the Y. All right, now we have to pay attention to how it words things. So it says every package must provide at least 6 units of protein, at least. So the symbol we're going to put here is going to be greater than or equal to, the number it gave us was 6. For carbs, at least 10 of the carbs. So again, greater than or equal to, and there's 10. The fat, no more than 9. So it has to be less than or equal to 9. So that's going to help us fill out our chart and be ready to put all of that into our organizational chart and go from there. These are the things that are going to be our parameters. So now let's move to the form. So this is divided into 4 blocks, and our constraints are what we just created. And so I'm going to write those here. 3y was greater than or equal to 6, and 2x plus y was greater than or equal to 10, and x plus 2y was less than or equal to 9. And we want to turn all of those into y equals. All right, so we're going to have y, let's see, I'll do it this way, 3, whoops, I'm going to divide by the 3, so I just get y equals 2. All right, on this one, I've got y is equal to negative 2x plus 10. And on this one, do it down here, I've got 2y is equal to negative x plus 9. I'm going to divide everything by 2, and I have y equals negative 1/2 x plus 9 halves. So those are my 3 constraints. Those are the lines that I want to graph. And I'm going to graph them over here. I'm just going to do kind of a sketch to get what I need. So I'm going to go ahead and put some lines on here. I'm going to pause while I do that, and then I'll show you the line. Okay, so y equals 2, and in our constraints it also said that x had to be greater than or is equal to 0 and y had to be greater than or equal to 0. That's going to tell me I'm just going to be in this quadrant. All right, so for y equals 2, and this was a greater than or equal to, so it's a solid line going right there. That's y equals 2. For the negative 2x plus 10, I made 10 be up here, so I'm going to have a 10. That's my y-intercept. I'm going to go down 2 and over 1. And so I've got a dot there. And I'm going to come down just to about there. And this is the y equals negative 2x plus 10. And then I'm going to use a different color, and I'm going to go to 4.5. So 9 halves is 4.5. 1, 2, 3, 4, somewhere right here. And I'm going to come down 1 and over 2. And it actually should be a little bit better than that. Let's see. I think that blue one's going to come about there. If we did all the shading and checking on the shading, we would end up with this being our feasible region there. And so we need to find these corner points. And it's just easier to do this algebraically. So that's what we're going to do. We're going to move down here to finding the intersection points. So what we need to look at, actually, I'm going to kind of highlight this with a color, and I'm going to highlight that with a color. So I've got that blue, that green, and let's do this one with yellow. All right. So let's come down here. If I want the intersection of this green and this blue, that would give me this dot here. I need these two equations. All right. So I'm going to come down here and I'm going to say we're going to have y. Let's do red. We're going to have y equals 2 and y equals negative 2x plus 10. Y is equal to both of those, so where they intersect, we're going to put that equal to that. So we've got 2 equals negative 2x plus 10. I'm going to subtract 10, so I have negative 8 equals negative 2x. Divide by negative 2, I get 4 is x. So 4 is x, y is 2, so my point, my intersection point, is 4, 2. All right. Now, let's look back up here. If I want this intersection point between the green line and the yellow line I didn't write down up here, but this is y equals negative 1/2 x plus 9/2. So I'm going to take that line and my y equals 2, and I'm going to come down here and write that one. So I've got y equals 2 and y equals negative 1/2 x plus 9/2. I'm going to set these two equal to each other. So 2 equals negative 1/2 x plus 9/2. I'm going to subtract this 9/2 over here, knowing that 2 is equal to 4/2. So if I subtract negative 9 from that, I get negative 5/2 equals negative 1/2 x. If I divide by negative 1/2, this is going to end up being positive, and if you divide by a fraction, you multiply by its reciprocal. So you're multiplying by that. So x is going to be 5, because those 2's will cancel out. So we have x is 5, y is 2. So now I have another point. I've got 5, 2. Draw another line. So the last combination that I have to get is this blue line, the y equals negative 2x plus 10, and the yellow line, so this point up here. So let me write those two down. So we have y equals negative 2x plus 10, and y equals negative 1/2 x plus 9/2. I'm going to put those equal to each other. And so I have negative 2x plus 10 equals negative 1/2 x plus 9/2. I'm going to multiply everything through by 2. That's going to get rid of all my fractions. So I'm going to have negative 4x plus 20 equals negative x plus 9. I just got rid of the fractions. That makes it easier. So I'm going to add x to this side. So I have negative 3x. And I'm going to subtract 20 over here. That's going to give me negative 11. I'm going to divide, and I get x is 11 thirds. But in this one, I have to then also plug in y. I ran out of a little room here, but I'm going to say y is equal to negative 2 times 11 thirds plus 10. So y is equal to negative 22 thirds plus 10. Well, 10 is 30 thirds, so 30 minus 22, y will be 8 thirds. So I have my third and final point, which is 11, whoops, which is, get the right color, and not erasing, okay, 11/3, comma, 8/3. All right, so we have filled in that finding the intersection part. Those are the 3 corner points. Remember that we're going to be evaluating, I lost my blue, whoops. We're evaluating z equals 20x plus 32y. Oops. All right, where did that come from? If we remember back up in our chart, the calories here is our objective function. So that's going in that last box there, and we're going to take these points and plug in here. So for 4, 2, we have 20 times 4 plus 32 times 2, and that equals 144. For 5 and 2, we have 20 times 5 plus 32 times 2. That's going to equal 164. For 11/3 and 8/3, we'll plug in, and we have 20 times 11/3 plus 32 times 8/3, and that equals 158 and 2/3. And we are looking for the smallest number. So 144 is our answer to that, and it occurs when you have 4 of the fruit and 2 of the nuts. So that is our solution, and we used this whole form to put everything in there. We started with the word problem, filled out the chart, then used the parameters that we came up with there. We turned them into equations. We sketched it. I would say really label so that you can see where your intersections are. Take 2 at a time, or however many it takes, how many times it takes, and get your intersecting points, and that is what you evaluate in the objective function. So hopefully that helps you get this organized.